Hello everyone. Welcome to PW. Good evening everyone. Please let me know by writing in the comment section whether audio and video everything is perfect or not. Please let me know by writing in the comment section beta ji whether audio and video everything is perfect or not. Great. Please let me know by writing in the comment section whether audio and video everything is perfect or not. Great. So till now we have completed entire combinational circuit and hoping all of you are now capable to solve any question based on the combinational circuit. It doesn't matter whether the question is designed on adder, subtractor, group adders, or your multiplexer, demultiplexer, decoder, encoder, any kind of question now you can easily solve. Today, I am going to start your new chapter. The entire digital electronics is in the two groups. First group is combinational, already completed. And now we are moving towards the second group, sequential circuits. Sequential circuit is very important, especially for GATE and all other competitive exams. Why, sir? Because every year, one question from sequential is there in every branch. If we talk about CS, computer science, electronics, ECE, that is electrical, IN. If you talk about any branch, there is one question and that question of 2 marks from sequential topic is present, and it is very easy to solve any question from sequential. There is one thumb rule. If you follow that thumb rule, you can solve any question based on the sequential. So before starting sequential circuit, I am just giving you that thumb rule. We will see that thumb rule in the upcoming lecture part. But what is that thumb rule? Whenever you have to solve any question from sequential circuit, just you have to do one thing. Before applying clock pulse, first find input to the flip-flops. Then apply clock pulse and follow the truth table. That's all you have to do. Almost 90% of the questions are going to solve with this thumb rule. So before applying clock pulse, first find input to the flip-flop, then apply clock pulse and follow their truth table. Is it okay? That is all you have to do. All questions are going to be solved. But how we are going to utilize this one line hack, that I am going to discuss in the lecture. Now please observe, the part that I am going to discuss today is your latches. We'll discuss about latches, we'll discuss about SR flip-flop, we'll discuss about JK flip-flop, D and T flip-flop as well. Okay? We'll discuss about D and T flip-flop. Now, please observe first, what is the basic difference between the sequential circuit and a combinational circuit? We can easily understand with the help of this block diagram. In sequential circuit, output depends upon present input and past state. Again, I am saying, in sequential circuit, output depends upon present input and previous state. Is it okay? Now, please observe, definitely in order to apply previous state, we need one memory element. So in sequential circuit, there is a memory element. However, in a combinational circuit, there is no memory element. In combinational circuit, output only depends upon the input. In sequential circuit, output depends upon the input as well as previous output. Is it okay? So now please observe here. Suppose if we have a basic block diagram to understand sequential circuit, so you can observe here, sir, output logic depends upon next state and previous state. Please observe here, whatever next state logic you want, suppose onto the flip-flop next state is Qn plus 1. So that Qn plus 1 depends upon two things. One is on your memory element, the previous state Qn. So Qn and present input. So based upon present input and previous state, your next state logic depends. Is it okay? Maybe your next state logic is the final output logic, or output logic is a function of next state logic as well as previous state logic as well as present input. Is it okay? There is a possibility that your final output depends upon present state, next state logic, as well as previous state logic. Is it okay? Great, sir. Now let's move towards the differences between the basic differences between the combinational circuit and a sequential circuit. Please observe, Betaji. Combinational circuit, the output variables, the output varies at any instant. The output better to write changes. The output changes at any time instant depending upon the present input variables only. However, if we talk about the output change or vary at any time instant depends on present input variable, also on the past history of the system. So that is the basic difference between the combinational and sequential circuit. It can be clearly observed that in a combinational circuit there is no memory element. However, memory elements are required in a sequential circuit. So that memory element is a latch. We are going to discuss the latch today. Okay. Next, combinational circuits are comparatively faster than your sequential circuit, and the reason behind is there is no feedback involved in a combinational circuit. However, a feedback is involved in a sequential circuit. Design is very simple for combinational circuit. Comparatively, the design is complex. Is it okay? If we talk about examples, combinational circuit already we have studied: multiplexer, demultiplexer, adder, decoder, encoder. So these are the examples of combinational circuit. Sequential circuit, flip-flops, counters, okay, registers. These are the examples of the sequential circuits. Is it okay? Great. So all of you are ready to understand latches now. See, the basic difference between combinational circuit and sequential circuit is, in sequential circuit, output depends upon previous state. So there must be some signal we have to give to retrieve that previous state. Is it okay? Yes, sir. Basically, this is in the terms of clocks. Until unless we are not going to apply the clock, the sequential circuit output state is not going to change. Is it okay? Great, sir. Now let's have a discussion on latch. The smallest unit of your entire sequential circuit is latch. If you are able to understand latch, you can easily understand flip-flops. If you are able to understand flip-flop, then register, counter, finite state machines, all will become very easy for you, because everything contains flip-flops. And to solve any kind of question, it doesn't matter whether asynchronous counters we are going to design, synchronous counters we are going to design, okay, state machine, melee, Murray, whatever we want to design, we have to only follow one thumb rule. Before applying clock pulse, first find input to the flip-flop, then apply clock pulse and follow the truth table. Okay. Now, but before going to all these things, let's have a discussion to the smallest unit of your entire sequential circuit, that is latch. So please write down latches. It is a basic memory cell. Latch is a basic memory cell that stores 1-bit data. Latches have 2 states, so it is also known as a bistable multi-vibrator, and the output of latches are Q and Q bar. Is it okay? Latches are the basic circuit which are further used to construct flip-flops. How many of you are able to understand up to this part? Great, sir. Now, if you remember, when we have studied NOT gate operation, there we have observed a stable multivibrator and a bistable multivibrator. So, if you remember that bistable multivibrator, then it has the 2 states. Can I represent like this? Yes, sir. Suppose the states are Q bar and Q. Whatever data you will give, that data will remain in the cycle. This is your inverter 1. This is your inverter 2. Can I rearrange this bistable multivibrator? Can I rearrange this bistable multivibrator in this way? Please observe, beta ji. Can I rearrange bistable multivibrator in this way? Now what happened? This is your inverter 1, inverter 2. So inverter 1 output is connected to input of inverter 2 and output of inverter 2 is connected to input of inverter 1. Can I represent like this? Yes, sir. Great. We have Q and Q complement, or you can say Q complement and Q. It's up to you. How many of you able to understand, beta ji? We can say one output as Q, another output as Q complement, or if you want, you can also represent like this. There is no issue. How many of you able to understand this? How many of you able to understand this? Great, sir. But the issue is, if we design a latch, this is what we call a latch. If we design a latch by using NOT gate, then we don't have any control over the latch. Don't have any control over the latch means Sai Kumar, you have already connected, I think, in the paid batch and you have completed. So, what is your doubt? English batch, I didn't crack it. I have an idea regarding concept little right now. How can I start my preparation to achieve good rank in GATE? Beta ji, the only thing is you have to go with the number of questions, revise the concepts again and again, okay? And complete your syllabus. Whatever topics are left out, you have to cover. I am hoping your answer is already I have given, okay? So now let's come back to latches. If we talk about latch, what is the basic difference between the latch by designing by the NOT gate? Sir, if we are going to design by the NOT gate, then we don't have a control over the latch. It means we can't provide the input. If you observe, here we are getting two inputs. Is it okay? So either we have to use wired AND or a wired OR. So if we are going to use wired AND or a wired OR, depending upon the type of circuit we are going to design, it will work. We don't have a control if we directly design with latch. It would be better to design by using NAND gate or a NOR gate. So let's have a discussion. Latches on by using NAND gate. Okay. Just a minute. Let us first discuss NAND latch. When the latch is designed by using NAND gate, latch is called NAND latch. Now, if we observe NAND latch can be represented like this. Now, we can have a control over the latch. It means if we want to store the data or restore some data, it is possible. Please observe, beta ji. Sir, foundation cover for CSC, yes, beta ji. YouTube full fundamental cover concept gate. Of course, beta ji, we have run this series for the same, na? We are going to cover the complete subject along with the fundamental concepts, okay? All fundamental concepts we are taking care of. Only you have to go through the number of questions. If you are just going through this series na, and solving your questions, PYQ questions, you will be able to understand the entire subject in a very well way. And then you have to only go through the test series. That's all you have to do. For the particular subjects which you are going to cover from this series, na, that subject you can easily answer all the questions. It doesn't matter how much they are going to twist. Okay. Now please observe NAND latch. So in a NAND latch, In a NAND latch, we generally called it as SR. But there is nothing called as SR in a NAND latch. Latches don't have any fixed truth table. Please listen very carefully. Latches don't have any. Latches don't have any. Beta ji, let me answer. Someone is asking something in the comment section that he is able to understand all the concept but failed in solving the problem. See, beta, it means you are not practicing. You know how to drive the car, but unless you will start driving the car again and again, how would you become a perfect driver? Huh? The same goes for the concepts as well. You know the concept, but you have to apply the concept in the different questions. So start doing it through the great PYQs and keep one solution book with you. If a solution book is with you, first observe the question, open your particular topic wherever you have mentioned the notes. Try to solve the question by your own for 5 minutes, 10 minutes. If you are unable to solve or unable to approach towards the question, then observe the solution. Definitely, if you have completed your entire lectures, you will be able to understand the solution in a very well way, and you will also understand what concepts you are unable to link up. Is it okay? So first 2 questions, 3 questions, 4 questions. After 4-5 questions, you will be able to find out that now I can approach towards that kind of questions. Is it okay? This is the only way. This is the only way. Every mind is different. I can't transfer directly my thought process to you. I can make you the concept to understand your the particular concept. But how these concepts are going to utilize to solve a particular numerical, also we are just telling all the concepts related how to solve everything, but you have to do more and more practice. Now come back to the particular one. We are talking about NAND latch. So in a NAND latch, we have SR and output. Let us suppose output is Q and Qn complement. I can say any one of them as Q and any one of them as Qn complement. Any one of them as S and any one of them as R. No one can say which one is S and which one is R. Is it okay? So there is no fixed truth table for the latches. Keep this in your mind. There is no fixed truth table for the latches. To understand the functioning of this particular circuit, I am constructing truth table. We all know about the truth table. Truth table contains all the possibilities of inputs and outputs. So please observe here, we have an input I have named S and R, and I am interested to get the next state available at this. Present state is Q, next state is Q1, Q. Present state is Qn, next state is Qn plus 1. Present state is Qn bar, next state is Qn plus 1 complement. So I am interested to get Qn plus 1, Qn plus 1. I am observing at this particular port next state. Okay. Yes, sir. Sir, latches don't have any fixed truth table. Yes. Latches don't have any fixed truth table. So how to solve latches problem? Please observe, beta ji. Latches don't have any fixed truth table. Suppose if I am considering the input to latch is S and R, then how many possible combination? 4. Either both are low, any one of them is high, or both are high. Now please observe, we all know about NAND gate. A NAND gate will have disable 0. It means if one input of a NAND gate is 0, then finally its output is going to be 1 only. If one input of NAND gate is 0, NAND gate get disabled. So how to approach towards latches? Always follow disable. For latches, always follow disable. So I am writing a note point here. For latches, always follow disable. What is disable for NAND latch, beta ji? For NAND latch, follow logic 0. Why? Because 0 is a disable for a NAND latch. Now please observe here. If you observe this particular condition, 0, 1. Let's first get started with 0, 1. So please observe 0, 1. It means when S is equals to 0 and R is equals to 1, then what is at Qn and what is at Qn plus 1 and Qn plus 1 complement? What is the difference between Qn and Qn plus 1? Qn is the present state, Qn plus 1 is the next state. Is it okay? Yes, sir. I don't know what is Qn and what is Qn complement. I don't want to know about Qn and Qn complement if S and R, one of them is 0. So since S is 0, you have to follow 0. It doesn't matter what is your previous state of Qn and Qn complement. It doesn't matter what is the state of Qn and Qn complement. If S is 0, then we all know 0 multiplied by anything is 0 and its complement is 1. So one thing is clear, that next state Qn plus 1 is going to be 1 only. Is it okay? Since it stabilizes as 1, so this 1 will come here and R is also 1. So 1 into 1, its complement is 0. So now we also know that Qn plus 1 complement is going to 0. So now we are able to understand here, in case if S is a 0, R is 1, we are getting Qn plus 1 as 1. Please observe once again. Suppose next input to S and R is 1, 0. So if S is 1 and R is a 0, if S is 1 and R is 0, you have to follow disable. Disable for NAND is 0, so you have to follow 0. Now R is 0. We all know it doesn't matter what is Qn and what is Qn bar. If R is 0, 0 multiplied by anything is 0 and its complement is 1. So it means this output Qn plus 1 is going to stabilizes as 1. So this 1 will come here and now 1 into 1, its complement will become 0. So at Qn plus 1 we are getting 0. Hoping all of you able to understand up to this part. Great, sir. What happens for 1, 1, sir? Let's have a discussion for 1, 1. What happens for 1, 1, sir? Please observe, Bitaji, very important. If you are able to understand latch, then everything will become very easy for you. Please observe, sir, what happened if we are going to apply 1, 1, S is 1 as well as R is 1. Now S is 1, R is 1, it means both the gate of a latch are enabled. When both the gates of a latch are enabled, now the output depends upon previous state. Is it okay? Please observe. There are two possibilities. Before applying input S is equals to 1 and R is equals to 1, there is a possibility Qn 0. If Qn is 0, Qn bar is 1. Is it okay? Yes, sir. Now, another possibility, maybe before applying S is equals to 1, R is equals to 1, let us suppose output is 1. If Qn is 1, then its complement is 0. Is it okay? So first consider this case, yellow one. So this yellow one case is indicating before applying clock pulse, before applying input S is equals to 1 and R is equals to 1. Before applying input S is equals to 1 or R is equals to 1, let us suppose we have a present state Qn bar as 0, 1. Is it okay? Yes, sir. So for yellow as a present state and S1 R1 is the present input, what happens to the next state? Please observe, we have to follow 0 again. If this is 0, so we have to follow this again. 0 is coming here. 0 into 1, 0, its complement is 1. So definitely this Qn plus 1 complement stabilizes to 1. Now this 1 will come here. This 1 will come here. 1 into 1, its complement is 0. So this will become 0. So what it indicates, if previously 0, we are again getting 0. If previously 0 and S is equals to R is equals to 1, we are again getting 0 only. Another possibility, before applying the input S is equals to 1, R is equals to 1, let us suppose the pink one is your present state. So for a pink one as a present state, that is Qn is 1 and Qn bar is 0. I am considering. Let us suppose this is the present state and now you are going to apply input S is equals to 1, R is equals to 1. Then what happened? Sir, this is 0, so we have to follow 0. 0 into 1, its complement will become Sir, 0 into anything is 0, complement is 1. So here we are again getting 1. 1 will come here, 1 into 1, its complement will become 0. We are again getting 0. So it means when both are 1, 1, both the logic gate gets enabled, we are getting our next state. Qn plus 1 is the next state, same as previous state. How many of you able to understand? Please let me know by writing in the comment section, beta ji. How many of you able to understand up to this part? Please let me know by writing in the comment section. Beta ji, I need your response. It's very important. Latches don't have any fixed truth table. You don't know which one is S and which one is R. They may give you P1, P2, Q1, Q2 and so on. So always follow disable for latches. Latches don't have any fixed truth table. The basic difference is latches don't have any fixed truth table. However, the defined flip-flop will always have a fixed truth table. Now again, come back to the last one. What happened for the 0-0 case? What happened for the 0-0 case? If we talk about 0-0 case, then please observe beta ji. Please observe beta ji. If we talk about 0-0 case, 0-0 means both input S and R are 0-0. If input S to 0 and R to 0, if input S to 0 and R to 0, if the input S to 0 and R to 0, then both the gate get disabled. When both the logic gate get disabled, it doesn't matter what is your previous state, because 0 multiplied by anything is 0 and its complement is 1. 0 multiplied by anything is 0, its complement is 1. We can't define this state. Why? Because if I am saying Qn is equals to 1, then I can't say Qn bar is also 1. It is happening, but we can't define this state. As per this state, we can say both the outputs as Qn. But if I am going to say both the outputs as Qn, then rest of the three states are undefined. Is it okay? Yes, sir. So we can't define this state as both the outputs are becoming same. However, in the rest of the three cases, they are complement to each other. So we say this state as a invalid state, and we avoid this state in the flip-flop operations. So this is a invalid state. Because if we are going to define the pins as per this state, rest of the three states will become invalid. How many of you able to understand? We are getting 1-1. We are getting 1-1. Until unless there is no difference in the delay of these two logic gates, we are getting the same 1-1 at same time. Is it okay? How many of you able to understand up to this part? Great, sir. So now we know about first part, that is NAND latch. So latches don't have any fixed truth table. Always follow disable for the latches. Let's have one more, that is NOR latch. If the latch is designed by using NOR gate, if the latch is designed by using NOR gate, then latch is called NOR latch. So NOR latches are those latches which are designed by using NOR gate. So this is what we call NOR latch. How many of you able to understand? How many of you able to understand? Please observe here. Now we have SR and two NOR gates connected in the same fashion. The output of one NOR gate, one input of NOR gate is connected to the output of one NOR gate, and one input of the NOR gate is connected to the output of next NOR gate. Is it okay? Yes, sir. So if you observe a NOR latch, then in a NOR latch, I have represented here Qn bar and here Qn. Is there any specific purpose? No. We can say this Qn bar, this R, this S. There is no matter for this. Is it okay? Absolutely no matter. Please observe We don't have any fixed input, because how would you know which one is a latch 1 and which one is a latch 2? Both are like this. Is it okay? Yes, sir. So just for the representation, just to let you know that the latches don't have any truth table, I have represented like this. So please observe now. Please observe now. S is equals to 0 and R is equals to 0. How many possibility for the input? 0, 0, 0, 1, 1, 0, 1, 1. There are only 4 possibility with the input S and R. Let us take first this one. S is equals to 0 and R is equals to 1. S is equals to 0 and R is equals to 1. For latches, latches don't have any fixed truth table. For latches always follow disable. So for latches always follow disable. For NOR latch follow logic 1. Why beta ji? Because for NOR latch logic 1 is a disable. For NOR gate logic 1 is a disable. So always follow logic 1. Now please observe here. For this particular condition, S is equals to 0, R is equals to 1. If this is 1, irrespective of the previous state, Qn plus 1, irrespective of the Qn bar, if SR is equals to 1, then we all know 1 plus anything is 1 and its complement is 0. So it means Qn plus 1 is going to stabilize this as 0 only. We are observing the next state at this particular port. So we are getting 0. Now this 0 will come here. 0 plus 0. 0 plus 0 is 0. Its complement will become logic level 1. So we are getting 1 here. Is it okay? Yes, sir. So Qn plus 1. We are getting Qn plus 1 as we are getting Qn plus 1 here, that is 0. For S is equals to 0 and R is equals to 1. For S is equals to 0 and R is equals to 1. We are getting Qn plus 1 as 0. How many of you able to understand? Great, sir. Let's have for S is equals to 0, R is equals to 1, we are getting logic 0. Is it okay? Yes, sir. How many of you able to understand up to this part? Now please observe this one. For S is equals to 1 and R is equals to 0. For S is equals to 1 and R is equals to 0. For S is equals to 1 and R is equals to 0. Please observe beta ji. Qn plus 1 complement. For S is equals to 1 and R is equals to 0. Always follow for NOR latch. For NOR latch, always follow logic 1. So if we have S is equals to 1, then it doesn't matter what is Qn and what is Qn bar. If S is equals to 1, 1 plus anything is 1, its complement is 0. Now this 0 is coming here. 0 plus 0 bar, this is 1. So for S is equals to 1 and R is equals to 0, we are getting 1. How many of you able to understand up to this part? Let's have 0, 0. What happened if S is equals to 0 and R is equals to 0? What happened if S is equals to 0 and R is equals to 0? What happened if S is equals to 0 and R is equals to 0? If S is equals to 0 and R is equals to 0, please observe. For S is equals to 0 and R is equals to 0, both the latches will become enabled. For S is equals to 0 and R is equals to 0, both the latches become enabled. Yes, Betaji, it is almost a full course only. Please observe, S is equals to 0, R is equals to 0, both the latches will become enabled. Now, depending upon the previous state, we have the next state. Please observe how many possibility of the previous state. Maybe before applying S is equals to 0, R is equals to 0, your previous state Qn is a 0 and Qn bar is 1. So if Qn is 0, then what happened? This 0 will come here. 0 plus 0 complement will become 1. So you will get 1 again. And 1 will come here. 1 plus 1, its complement will become 0. So you are getting 0 again. So if we have previously 1, 0, then for input S is equals to 0, R is equals to 0, we are again getting Qn plus 1, 0 and Qn plus 1 bar as logic level 1. Is it okay? Yes, sir. There is one more possibility. Please observe. Maybe your previous state, before applying S is equals to 0, R is equals to 0, maybe your previous state is 0, 1. So in this case, what happened? This 1 will come here. 1 plus 0 complement. 1 plus anything is 1, its complement is 0. So we are getting 0. 0 will reaches here. 0 plus 0, its complement will become 1. We are getting 1. So we have observed Qn plus 1 is the same as a Qn if S is equals to 0 and R is equals to 0. If Qn is 1, again we are getting Qn plus 1 as 1. If Qn is 0, we are getting again Qn plus 1 as a 0. So it means for 0, 0, when both the logic gates get enabled, we are getting previous state. How many of you able to understand, Betaji? Now come to the last one. That is 1, 1. What happened if both the inputs are 1, 1? What happens if both the inputs are 1, 1? If both the inputs are 1, 1, then irrespective of the previous state, both the logic gates get disabled. If their delay is the same, then 1 plus anything is 1, its complement is 0. 1 plus anything is 1, its complement is 0. So we are getting Qn plus 1, 0, as well as Qn plus 1 complement also 0. We can't define this state, because if we want to define this state, we have to say this and this both Qn. If we are going to say these two as Qn, then rest of the three state will become undefined. So we can't define this state in case if both will have a same delay. So we say this state to be a invalid state. Now mostly student just try to memorize this particular truth table and say 1, 1 is disabled. 1, 1 is a invalid. 1, 1 is a invalid for a NAND latch or a NOR latch. Very important. Please observe. For a NAND latch, 1, 1 is same as previous state. However, if the latch is designed by using NOR gate, 1, 1 will become invalid and 0, 0 will become previous state. Is it okay? Great. So never try to memorize the truth table of latches. Latches don't have any fixed truth table. You can't decide which one is the first and which one is the second. Is it okay? So latches don't have any fixed truth table. Whatever latch is given to you, just follow the disable of the logic gate with which latch is designed. Hoping all of you able to understand up to this part. Great, sir. Now, we'll discuss this later on. Can you answer this question? This is a gate question. It's a gate PYQ. Can you solve this question now with the concept which I have discussed just above? Please observe. Refer to the NAND or NOR latches as shown in the figure. The input P1, P2. The input P1, P2 for both the latches are first made 0, 1. And then after few seconds made 1, 1. The corresponding stable outputs Q1, Q2 are. Now you can't memorize because you don't know which one is S, which one is R. Here it is P1, P2. Is it okay? Yes, sir. So how to solve this now? Please observe. Always follow disable. This is a NAND. This is a NAND gate. NOR gate. Now please observe. First we are going to apply P1, P2, 0, 1. So first we are going to apply P1, P2, 0, 1. When P1 is a 0 and P2 is 1. P1 is a 0 and P2 is 1. For NAND latch, always follow disable. Disable for NAND gate is 0. So follow 0. 0 multiply by anything is 0. I am representing it by using this yellow color. 0 multiply by anything is 0 and its complement is 1. So definitely your Q1 stabilizes. Q1 stabilizes to 1. And now 1 will come here. 1 into 1 complement will become 0. This is 0. Q2 will become 0. Is it okay? Yes, sir. So NOR NAND gate first become 1 0. NAND gate first become 1 0. NAND gate first become 1 0. This is not 1 0. This is 1 0. This is 1 0. This is 1 0. So option A can't be the answer. Let's have to verify the rest of the things. Now come to the latch, NOR latch. For input 0 1 always follow disable, because if this is 1, we don't know about the previous state. We don't want to know about the previous state, because if any one of them makes the particular gate disable, follow that. 1 plus anything is 1, its complement is 0. So this Q2 will become 0. Now this 0 will come here. As Q2 stabilizes to 0, so 0 will come here. 0 plus 0, 0, complement is 1. So Q1 will become 1. It means with the input P1 is equals to 0 and P2 is equals to 0, NAND first becomes 1 0 and NOR first becomes 1 0. NAND first becomes 1 0 and NOR first becomes 1 0. Now we have option B or C. Is it okay? Now please observe, after few seconds input changed. After few seconds input changed to the green one. What is the green input? Input changed to 1 1. When the input changed to 1 1, then when the input changed to 1 1, then both of these gates get enabled. Both of these gates get enabled. Yes, sir. So under that condition, output will remain same as the previous. Is it okay? Yes, sir. So output will remain same as the previous, as both will become enabled, and also the previous is 1 0, a valid state. So we will again get 1 0 as Q1 1 and Q2 0. Is it okay, beta ji? Yes, sir. So we are getting 1 0. We are getting 1 0. So in both we are getting 1 0. Come to this. P1 is changed to 1. P2 is changed to 1. Now for both the inputs of a NOR latch 1 1, both the NOR gate gets disabled and we will get the output as 0 0. This is an invalid state. Is it okay? We may get some intermediate state. It depends whether the logic gates will have same delay or not. If they have same delay, we will get 0 0. So how many of you able to understand that C is the correct answer among all? Hoping all of you able to understand this question perfectly. Can you answer this one? In a figure, A is equals to 1 and B is equals to 1. The input B is now replaced. Input B is now replaced by a sequence 1 0 1 0 1 0 1 0 so on. The output X and Y will be. The output X and Y will be. Please observe, beta ji. We have A and B. We have A and B, and we want output at X port and Y port. Is it okay? So A and B is first A and B are 1 1. First A and B are 1 1. So we don't have the output X and Y because it depends upon the previous state. We don't know about the previous state. Forget about it. Now B is changed. Now B is changed to 1 0 1 0 1 0. Now B is changed to 1 0 1 0 1 0. Is it okay? Yes, sir. We can't say anything about this. We can't say anything about this, but we can say the state for this. Soon as B will become 0, 0 multiplied by anything is 0 and its complement will become 1. So Y stabilizes to 1. When this is 1, 1 into 1, its complement will become 0. So we are getting X as a 0. Is it okay? Yes, sir. Now we are going to apply 1. So again we will get previous state. What is previous state? 0, 1. Again we are applying 0. So when we are applying 0, same happen, you will get 0, 1. So it doesn't matter if you are going to apply the sequence 1 0 1 0 1 0 1 0 1 0, then x will remain low and y will remain high. How many of you able to understand? So x is fixed at 0 and y is fixed at logic level 1, irrespective of the previous state. How many of you able to understand this part perfectly? Please let me know by writing in the comment section, beta ji. So for latches, always follow disable. For latches, always follow disable. How many of you able to understand, beta ji? Please let me know by writing in the comment section. Please let me know by writing in the comment section. Now latches are used in designing of the flip-flops. We have different flip-flops. Let's have a discussion on to the flip-flops. Now please observe. Now please observe flip-flop. If we talk about flip-flops, flip-flops are designed by using latches only, but the flip-flops will have a fixed truth table. Flip-flops will have a fixed truth table. Is it okay? Yes, sir. So, flip-flops have two outputs, Q and Q complement. Is it okay? It can store 1 bit data. If we talk about types of flip-flops, then we have SR flip-flop, we have JK flip-flop, D flip-flop, and T flip-flop. To understand any flip-flop or to use any flip-flop, we must know about 3 tables. First one is called as truth table, second one is called as characteristic table, and third one is called as excitation table. Characteristic table characterizes the behavior of the flip-flop. Excitation table tell us how to use the flip-flop in our application. Is it okay? And truth table is a part of characteristic table which indicates for the different input what will be the sure next state outputs. Is it okay? Yes, sir. So for all flip-flops, we are going to study 3 important tables. Is it okay? First is your truth table, second is your characteristic table, and third is your excitation table. Hoping all of you able to understand up to this part. Let us first discuss about SR flip-flop. There is no SR latch. Latches don't have any fixed truth table, but there is a SR flip-flop. Flip-flops will have a unique truth table. Flip-flops will always have unique truth table. Flip-flops will always have unique truth table. Now please observe this flip-flop. Beta ji, first observe SR flip-flop. So if we talk about SR flip-flop can be designed by using either a NAND gate or by using NOR gate. So first I am using by using NAND latch, SR flip-flop by using NAND latch. In SR flip-flop, we have 2 inputs S and R, and we have 2 outputs QN and QN complement. Always remember, in SR flip-flop, front of S is always QN and front of R is always QN complement. This is sure. Why? Because flip-flops will have unique truth table. Is it okay? So whenever you are having a SR flip-flop, it always work uniquely. S, the front value of the S is corresponding to Qn, and the front value of the R is showing the result of Qn complement, output Qn complement. Now please observe, I am representing a level triggered clock. So this is your clock. Now please observe beta ji, the internal circuitry of this SR flip-flop. Internal circuitry of this SR flip-flop. Please observe SR flip-flop by using NAND latch. So SR flip-flop by using NAND latch, how it would look? Sir, we have two NAND gates working as a steering gates or a control gates. These two NAND gates are going to control the NAND latch. So they are called as a steering gate or control gate. The output of one connected with the input of other. Output of one is connected to the input of other. This is your Qn and this is your Qn complement. We have a input SR and we have a input clock. So all of you have remember a stable multi-vibrator, also called as a clock generator. So you can just observe here we have a clock. Whenever the level is high, you can say clock is 1. Whenever the level is low, you can say clock is low. Now please observe, in order to understand SR flip-flop, we can construct its truth table. So now please observe the truth table of SR flip-flop. So how many possibility with a 2 input SR? 4 possibilities, sir. 4 possibilities, sir. I am interested to check the next state at this particular port. So I am interested to check Qn plus 1 as a next state. We have a input SR, next state Qn plus 1 and clock. In case if clock is low, what happened? In case if clock is low, 0 multiplied by anything is 0, its complement is 1. 0 multiplied by anything is 0, its complement is 1. So it doesn't matter what is the value of S and R. Onto the NAND latch, we are getting 1, 1. Onto the NAND latch, we are getting 1, 1. Onto the NAND latch, we are getting 1, 1. And we have observed onto the NAND latch, if the inputs are 1, 1, then the output is same as previous state. So the output will remain in the previous state. What it indicates? It indicates until unless there is no clock, there is no change in the output. Output will be remain same. In other word, I can also say until unless there is no clock, the circuit is not activated. The circuit only activates and provides output as per the input when the clock is applied. If there is no clock, there is no change in the input. There is no change in the output. Output will remain in its state. So output will remain in Qn state. Is it okay? Now, if clock is high, then with a high clock we have 4 possibility. Either SR00 or SR01, 10 or 11. With a high clock we have 4 possibilities. With a high clock we have 4 possibilities. Yes sir, let's check each of them. Now with a high clock, if S is 0 and R is 0, if clock level is high and S is equals to 0 and R is equals to 0. 0 multiplied by anything is 0, its complement is 1. 0 multiplied by anything is 0, its complement is 1. In NAND gate, if any input is 0, then output is logic level 1 only, because 0 multiplied by anything is 0, its complement is 1. So we are getting 1, 1 again. It means with the input S is equals to 0, R is equals to 0, if we apply clock, the next state will remain hold. So this state is called as a hold state. How many of you able to understand, beta ji? This state is called as a hold state. Great. Sir, I have a doubt. Hope you reply me. You can ask, beta ji. You have deleted your message. How can I reply now? See, 0, 1. If S is 0 and R is 1, please, if whatever you want to ask, please feel free to ask, Bitaji. If anyone want to ask anything, please feel free to ask. See, if you are going to follow only 2 classes of the sequential, na, you can solve any question based on the sequential. Doesn't matter whether you have read or not. Please see next. With S is equals to 1, what happened? With S is equals to 0, R is equals to, with S is equals to 0. Now let's have a 0, 1 condition. So when S is equals to 0 and R is equals to 1 with a high clock, So if clock is high, then 0 multiplied by 1 will give you logic level 0 and its complement will become 1. And here we are getting 1 into 1, its complement will become 0. So onto the NAND latch, we are getting 1, 0. If this is 0, then 0 multiplied by anything is 0. Output is logic level 1. So Qn bar stabilizes to 1. Now 1 will come here. 1 into 1, its complement will become 0. So, sir, we all can say Qn plus 1 complement. Let me show you once again. See, with the 1 into 1, clock is high, R is high. So 1 into 1 complement is 0. If any one of the input of NAND latch is 0, then always follow 0 for NAND latch, because for NAND gate 0 is disabled. 0 multiply by whatever will be your input Qn, it doesn't matter. We are interested to find out the next state Qn plus 1. So if this is 0, 0 multiply by anything is 0. So whatever will be the value of Qn. 0 into Qn is 0, its complement is 1. So Qn plus 1 complement stabilizes to 1. This 1 will come here. 1 into 1, its complement will become 0. So this will become 0. So when reset is high, it reset the flip-flop. That is why the name given as a set reset flip-flop. Since reset is high, set is low. So it resets the flip-flop. Reset is high, so it resets the flip-flop. It doesn't matter what is Qn, but if you are going to apply onto the S as a 0, onto the R as 1, it will reset the state. Now please observe for 1, 0. What happened for 1, 0, Bitaji? Please observe next 1, 0. If we talk about 1, 0, please observe for 1, 0. For 1, 0. If you talk about 1, 0, sir, we don't know about the previous state. Okay. We are going to apply S is equals to 1, R is equals to 0 and a clock high. So 1 into 1 complement is 0. 1 into 0, 0 complement is 1. For NAND latch, always follow 0. So if this is 0, then 0 multiplied by Qn bar is a 0 only, and its complement is logic level 1. So this Qn plus 1 stabilizes to logic level 1. Now 1 will come here. 1 into 1 complement is 0. So you can say, sir, Qn plus 1 will become 1. It means when set is high and reset is low, again we are getting set. So now for reset high, we are getting reset. For set high, we are getting set. Is it okay? That is why the name given set reset flip-flop. Now come to 1, 1. What happened in case if we are going to apply 1, 1 and a high clock pulse? I need a response from everyone in the comment section, Bitaji. Are you able to understand this or not? Please let me know by writing in the comment section, Bitaji. See, if we are going to apply both 1, 1 and a clock is applied as high, then 1 into 1 complement is 0, 1 into 1 complement is 0. Onto the NAND latch, if both the inputs are 0, 0, both the outputs will become 1, 1, which is an invalid state. So we say this as invalid state. How many of you able to understand? Invalid state is avoided in the normal flip-flop operation. What is the demerit of SR flip-flop? Invalid state. Demerit of SR flip-flop, invalid state. Invalid state must be avoided in the normal flip-flop operation. How many of you able to understand? Someone is asking Sir, I am currently in 4th SEM, and Chandan Kumar is asking, and SEM exam will be conducted on October. So can I eligible to give gate? You are on your 4th SEM, na? Yes, beta ji. Third year, you are eligible to give your exam on in your third year. Okay. So yes, you are in 4th SEM now. In the winter, you will reach to your 5th SEM, and after 5th SEM, you are eligible to give your exam. Okay. In third year and final year, you are eligible to give your exam. Okay. Great. Now, how many of you able to understand up to this part? If there is any doubt in anything, please feel free to ask. If there is any doubt in anything, please feel free to ask. I'm just removing all these entries so that you can check once again by your own. Okay, I have mentioned here, you have to check in the same way. Hoping all of you able to understand the SR flip-flop, beta ji. Now, if we talk about SR flip-flop, SR flip-flop can also be designed by using NOR latch. Let's have a discussion of SR flip-flop by using NOR latch. So, SR flip-flop by using NOR latch. First two logic gates are steering gate. I'm using AND gate as a steering gate for a NOR latch. And we have NOR latch. Okay. Now, please observe, beta ji, we have S, R, and clock. And I am going to design it like this. Why? Let you know very, very soon. Please observe first. So basically, this is your SR latch. This is your SR latch, SR flip-flop by NOR latch. So it can be clearly observed, this portion is representing a NOR latch. Why I have made like this? Because I just wanted to show you the flip-flops will have a unique truth table. And in front of S always Qn, and in front of R always Qn complement. Okay. Yes, sir. Let's try to observe the truth table of SR flip-flop once again. So if we have a SR flip-flop, can represent clock S, R, and the next state Qn plus 1. And the next state Qn plus 1. Is it okay? Great. Now please observe everyone. Clock may be low. If the clock is low, then what happened? If the clock is low, we are getting 0, 0. And onto the NOR latch, if both the inputs are 0, 0, both the logic gates become enabled. It means we are getting same as the previous state, irrespective of the values given to S and R, it will remain in the previous state. It means until unless there is no clock, there is no output. Now, if I change with a high clock, then with a high clock, S and R will have 4 possibilities, either SR00, 01, 10, or 11. Is it okay? With S high, with SR, we have 4 possibility with a high clock. So clock is high. Now with S is equals to 0 and R is equals to 0, we will get, sir, 0 multiplied by 1, 0, 0 multiplied by 1, 0, because the basic AND gates. 0, 0 onto the NOR latch, if we get 0, 0 onto the NOR latch, if we get 0, 0, then after at the output we will get same as the previous state. It indicates hold. It means you are applying such a input to SR flip-flop which holds the previous state again on application of the clock. Now come back to the next one. Suppose if S is equals to 0, R is equals to 1, S is equals to 0, R is equals to 1. 0, 1, this will give 0, 1, 1, this will give 1. For NOR latch, always follow 1, because if the input is 1, 1 plus anything will be Qn. Doesn't matter, anything will be Qn, doesn't matter. Because we are able to see here that 1 plus Qn is 1 only, and its complement will become 0. 1 plus Qn is 1 only, and its complement will become 0. So Qn plus 1 stabilizes to 0. Now this 0, Qn plus 1 stabilizes to 0. Okay, here we are Qn, we are getting Qn here. So please observe once again, we are getting Qn here. So Qn complement, we are getting Qn complement here. So 1 plus Qn complement, basically we are getting 1 plus Qn complement. 1 plus Qn complement is anything plus 1 is 1 only. So we are getting Qn plus 1 as 1. How many of you can see this? Sir, it's a NOR gate. It's a NOR gate means the complement to entire. 1 plus Qn complement is 1 only, and its complement is 0. So we are getting 0. Now this 0 will come here. 0 plus 0, 0, and its complement is 1. So on to the next state, we are getting 0. When reset is high, we are getting 0. Is it okay? Yes, sir. Again, please observe once again. Let's have a discussion to S is equals to 1 and R is equals to 0. S is equals to 1 and R is equals to 0. If S is 1, 1, 1, 1, we are getting 1, 0, 0. So 1, 0, we have to follow 1. It can be clearly observed 1 plus, what is the next input, Betaji? Next input is Qn. So 1 plus Qn, 1 plus Qn, 1 only, and its complement will become 0. So this state will become 0. Now when it stabilizes to 0, we are getting 0, 0 plus 0, 0 plus 0, 0 complement is 1. So we are getting 1 here. In case if set is high, we are getting 1. What happens to 1, 1? It can be clearly observed when both are 1, 1. We will get 1, 1 as the input to NOR latch. And if input to NOR latch is 1, 1, if input to NOR latch is 1, 1, we get invalid state. So input to NOR latch when becomes 1, 1, we will get invalid state. So input to NOR latch will become 1, 1, we get invalid state. So always remember, we are getting unique truth table for SR flip-flop. It doesn't matter whether it is going to be designed by using NOR latch or by using NAND latch. We are getting unique truth table for 0, 0 hold, for 0, 1 set, for 1, 0, for 1, 0 reset, sorry, for 0, 1 reset, for 0, 1 reset, for 1, 0, for 0, 1 we are getting reset, for 1, 1 we are getting set. How many of you able to understand? So now we know about the truth table. Now we know about the truth table. How many of you able to understand? Beta ji, there is no extra benefit of using NOT gate. Okay, ahead to this or ahead to this. If you want to use a NAND gate instead of AND gate, then the result will be in different way. How many of you able to understand? It doesn't matter whether someone is designing SR flip-flop in China or India. It doesn't matter. SR flip-flop must behave like a SR flip-flop. That's all. And that is what I want to represent with the two NAND latch and NOR latch. Is it okay? Now please observe, Betaji. All of you are able to understand the NAND SR flip-flop up to truth table part. If you are able to understand the truth table, please observe characteristic table now. Characteristic table characterizes the entire behavior of the flip-flop. So in SR flip-flop, characteristic table characterizes entire behavior of the flip-flop, it means we are able to understand Qn plus 1 based upon the present input and present state. So present input is SR, present state is Qn, and next state is Qn plus 1. You can please observe in the characteristic table. Please observe, Betaji. It characterizes the entire behavior of the flip-flop based upon present input and present state. Present input and present state, we can comment on to the next state. Present input is SR. Maybe present input is 0, 0. Maybe present input is 0, 0. Present input is 0, 1. Maybe present input is 1, 0. Maybe present input is 1, 0, or present input is 1, 1. Is it okay? Yes, sir. This is the present input. Present input 0, 0. Present input may be 0, S0, R0. Present input may be S0, R1. Present input may be S0, R1 or S1, R0, S1, R0, S1, R1, S1, R1. Present input. Present state. Present input 0, 0. Present state. Present input 0, 0. Present state may be 0, may be 1. Okay. Yes, sir. Present input 0, 1. Present input 0, 1. Present state may be 0, may be 1. Present input 0, 1, 0. Present state may be 0, may be 1. Present input 1, 1. Present state may be 0, may be 1. How many of you able to understand up to this part, Betaji? So in terms of present input and present state, we can comment on to the next state. Now, how to fill this table? Please observe. If we consider S as a MSB and Qn as a LSB, it seems like a binary condition from 0 to 7. So I'm just giving the numbering 0, 1, 2, 3, 4, 5, 6, 7. Now please observe, Betaji. In order to fill this table, we have to observe the truth table. In the truth table, we have found what is the next state Qn plus 1 for S0, R0, Qn. For S0, R0, we get hold state. So for S0, R0, we get hold state. For S0, R0, we get hold state. How many of you able to understand? Observe from truth table, so you will get hold state. Hold state is represented by Qn. Similarly, for S1, R0, for S0, R1, we get reset state. Reset means 0. That is reset. And for present input S1, R0, we get set state. Set means logic level 1. And for present input S1, R1, we get invalid state. How many of you able to understand up to this part, Betaji? Great. I have represented by a light color pen so that you can just group inside. How many of you able to understand? How many of you able to understand? Now, for a moment, forget about Qn. For a moment, forget about Qn. Don't rub this. Just I am saying forget about Qn. Just hide this Qn. Okay, and just observe S and R. So with S0, R0, next state is Qn. What is the meaning of Qn? If previously 0, we will get 0. If previously 1, we will get 1. For S0, R1, next state reset. Irrespective of the previous state, next state is reset. Please observe for S1, R0. For S1, R0, irrespective of the previous state, we get next state as 1, 1. And for S1, R0, we can't define the state, so we say invalid. We are not going to use this particular state. We are not going to make this appear onto the flip-flop. So the output is considered as don't care. How many of you able to understand? Now this will help you to understand characteristic equation as well. With S as a MSB and Qn as a LSB, we are getting Qn plus 1 high onto the binary condition of 1, onto the binary condition of 4, onto the binary condition of 5, 6 and 7 are don't care. 6 and 7 are don't care. How many of you able to understand, beta ji? Can we use K map to minimize the logical expression? Next state logic expression can be observed by the K map, S as a MSB and Qn as a LSB, R bar Qn, R Qn, R Qn bar. So we have 0, 1, 2, 3, 4, 5, 6 and 7. Where we are getting output logic high. We are getting output logic high onto the binary of 1, 4, 5, 6 and 7 are don't care. We have one pair, one chord and one pair. So Qn plus 1 called as characteristic equation. So characteristic equation will become S plus of R bar Qn. But this statement is only valid when S equals to R is not equals to logic level 1. Means both should not be equals to logic level 1. How many of you now able to understand up to this part? So we are not going to make this particular condition appear S1 R1 because S1 R1 is an invalid condition. Your output state will become invalid state. So we are not going to make this input to appear. So the outputs are considered here as a don't care. Those outputs are considered don't care, which input conditions are never going to be appear in the circuit. Is it okay? How many of you able to understand? Now next is your excitation table. Whenever we want to utilize our SR flip-flop, okay, in order to get the desired next state from the present state, we have to follow the excitation table. So excitation table is based upon present state and next desired state. So based upon present state Qn and next desired state Qn plus 1, we can find out excitation, that is input needed to S and R. Excitation needed to S and R. How many possibility, beta? Maybe we have Qn 0, okay, or maybe we have Qn 1. Present state may be 0, maybe 1. For present state 0, next desired state may be 0, maybe 1. For present state 1, next desired state may be 0, may be 1. So we have 4 possibility of present state and next desired state. If the present state is Qn is 0 and Qn plus 1 is also 0, then for 0, 0, please observe, characteristic table will help us to identify excitation needed. Please observe, beta ji. Please observe. For present state 0, next desired state 0. For present state 0, next desired state 0. What is the excitation needed onto the S? Excitation needed onto the S must be 0. However, excitation needed onto the R may be 0, may be 1. So it will be indicated as maybe 0, maybe 1. R can be anything, but if the present state is 0 and you want next state to be 0, then S must be 0. R may be 0, may be 1. Now please observe, for present state 0, next desired state 1. For present state 0, next desired state 1. For present state 0, next desired state 1. There is only one possibility. S is 1 and R is 0. S is 1 and R is 0. How many of you able to understand? S is 1 and R is 0. Now again please observe, for present state 1 and next desired state 0. For present state 1, next desired state 0, S is 0, R is 1. And if we talk about present state 1 and next state 1, then for present state 1 and next desired state 1, for present state 1, next desired state 1, for present state 1, next desired state 1, S may be 0, may be 1. So S may be 0, may be 1. R must be 0. R must be 0. It is very easy to remember. You can just remember one. This table is very important to solve numericals. Okay, questions based on the flip-flops. Please observe 0, 1, 0, 0, 0, 1, 1, 0, 1, 1. So you can just copy the first 3 to S. Last of the SR flip-flop is don't care, so just put don't care. Okay. If you remember for S, just reverse it. You will have the excitation needed to the R as well. How many of you able to understand? Great, sir. So in order to have present state, next desired state to get, we know what input is needed to apply on the SR flip-flop. Hoping all of you able to understand up to this part. Great. So I am keeping the class up to this part only. Rest JK flip-flop, D flip-flop, T flip-flop, I am going to discuss by tomorrow. Hoping you have enjoyed this session a lot. Lots of love. Thank you everyone. Please revise this session for tomorrow's class. Okay. Because we are going to discuss how to design any desired new flip-flop. Whatever flip-flop you want, you can design. So we will learn how to design any desired flip-flop, and then we will move towards the SR, and then we will move towards the registers as well. Okay, very important parts for your GATE exam. Thank you everyone. Lots of love. Thank you everyone. Good night.